To fill this out, what you need to do is you need to take your list of variables that we had, right? I'll take our list of variables, and you can go ahead and then on the next tab or in all of these tabs, you are going to fill it out, right? So all of these down below are the different variables that you can manipulate. And then these are the different variables that you can observe. So for the pendulum lab that we just had, let me go ahead and just take these ones right here. It should be easier for you to copy and paste these. Right. What you're going to do in this is these are all the different ones that you could do. And for all of these experiments, the dependent variable, the thing that we're looking for, is going to be the period. In each of these experiments, you are going to choose one of the independent variables based on these. Okay. And for the pendulum lab, I marked them off according to the different I marked them off in the different tabs as to which one is going to be the thing that you're experimenting with in the independent variable. So what I'll put down here is the independent variable amongst these variables. I'm going to put the length of the string. And what's nice about this, if I have listed out all my different control variables, what I'm going to do is I'm going to state that all of these other variables that I could manipulate, I need to make sure that I keep them the same. That's why we fill out this table, because when we've gone through the process of, hey, what are all the different things I can manipulate in this experiment? When it comes down to it, I choose one to manipulate. That's my independent variable. Everything else needs to be controlled in order to make sure that we have integrity within this experiment. And then what I do is once I'm in this pendulum lab, let's go. I have a little simulation for you right there. What I'm going to do is I'm going to set up the different values. So I'm going to be changing the length of the spring, but what I want to make sure I have is like, okay, the mass is going to be the same. I have to pick what my mass is going to be. I can leave it as 1 kilogram. That's fine, right? So I'll put in 1 kilogram. Starting angle. That means that every time I go through this experiment, I'm going to, Lord, too many tabs. I'm going to go ahead and set the same angle. Let's just say, I'll do it 30 degrees. Seems reasonable. So I'm going to set it at 30 degrees every time. Right. We get the gist of that. Once I've done that, once I've gone through and I've made a list of all these different things, what I'm going to do is I'm going to set this up to where this is what it looks like if it were to be filled out completely, right? I take my data, and when the length is 1.1 meter, then I'm going to measure what the period is. All these different simulations have nice, convenient little ways of measuring out the period. This has literally a period trace. And what it'll do also is you can set a stopwatch. That'll go ahead and take a time of what the period is, and you can take a look at that. And so what I've done is, again, period is the time it takes to go there and back again. Once I'm over here in the pendulum spot, I'm getting rid of this. In the pendulum spot, and I've taken my data. Then I'll end up getting a graph that looks like this, right? And so with what I've given you in the spreadsheet, you should have a graph sort of auto-populate as you fill this out. Okay, so then what you have is you have 2 questions to ask down here. Is this linear and is this horizontal? This is not linear. It is not horizontal. And what that means is I need to transform my data. If this were to be horizontal, then that would show me that there is no relationship. That means that no matter what I set the length of the string to, for instance, in experiment 2, the starting angle, when I go ahead and actually list all these different data points out, we pretty much have a horizontal line showing me that there is no strong relationship between my independent and my dependent variable, right? So that's if I have, it's not quite linear. It could be linear. That's fine. But then the horizontal thing, if I click that off, what I have here is I have this symbol. This sort of Jesus fish looking symbol that indicates proportionality. And over here, what it would say is says the period is not proportional to the starting angle. This is what it would look like if I am doing the experiment where I end up having a horizontal line and starting angle happens to be one of these different things. But what I'm going to do is I'm going to continue on with my experiment for experiment number 1, where I was taking a look at the length of the string. Okay, the length of the string, what I do with this is I see that it looks like it is sort of bowing off, and it looks to me like it's actually going to be a square root graph. So what I'm going to do is I'm going to, and we've done this before with the other graphs, it's what you did on your test, but essentially we're just going to be doing this over and over again with these different variables today. I'm going to transform my data like this. It looks like a square root graph. So what I'm going to do is I'm going to take the square root of the length. Over here, what I could do is I can make a formula in spreadsheets like this, and I could say this equals the square root of this first value that I have up here, right? Let's say I had a completely empty one, right? We're manipulating only the independent variable. I say it's the square root of this right here. And if you're lucky, oh yeah, I'm not lucky, and that's fine. What I could do though is Excel's a pretty smart guy, or Google Sheets. It's pretty smart. If I go like this for this cell, I've done this twice. If I highlight these and you look at this little blue dot down here with the little cross symbol that comes on up, that's saying that I can sort of take the format of this and extrapolate it on down. And what's going to do is it's going to take those values from this table up here and bring it on down here and square root all of them. And I end up getting a graph. And this is lovely because now I actually have a nice little line that ends up coming up on here. So I have a linear relationship. And when I have a linear relationship, that shows that the period is proportional to the square root of the length. These are things that we have done before when we were transforming the distance and time squared graph that you had on your test, in your FRQs, but now we're just changing it to different variables, okay? And then what I do is, I told you in the instructions, you don't have to fill out the reasoning category because that's my job to show you the reasoning. But what you would say is, the period is proportional to the square root of the length of the string, and that is your claim. And your evidence is essentially the graph that you have. When you take the square root of the string and you graph it along with the period, it ends up giving you a straight line. Okay, you're going to do that for each of the different variables. This video is here to help you out. Let me just talk about one thing earlier. Someone said, what is spring constant? Spring constant is just, if you take a look at the screen, what's happening when you change the spring constant. Yeah, exactly. I like that language. It's getting beefier, right? It is essentially how much resistance the spring will have. If it's a thicker spring, just like the suspension of a car, it takes a lot more to squish it into, to compress it and to extend it. However, it also has a lot more force going back. Have you all seen like the suspension bomb thing that's been happening on? I don't know. I see that one on Instagram. Anyway, so we're moving on. If it's something that's really flimsy, it's a little bit closer to like what's on the inside of that little spring mechanism over there I showed you in the beginning of class. Okay. Anyway, that is it. This is going to be a little bit of a struggle, I'm sure, in multiple ways, because a lot of you, I'm sure, are not that familiar with Google Sheets. And also, you're getting these different concepts. What I want you to get away from this at the end. First of all, I've listed out all these different steps. Those are the steps that I followed. Over here, at the end, I want you to list out all the different proportionalities and say whether or not they are something is proportional, if it's not proportional, if it's proportional to the square root or the inverse of the square root for both the pendulum and the mass on the spring. I'm sorry that was tedious. I'm sorry it was a lot to go through, but it is a lot of stuff that you're going to be doing. That was 10 minutes. It's fine. Jeez, it looks like I've been talking at y'all for a year. Michael.
So to turn this in, do you just want us to do the text entry, or do you want to do slides?
I want you to submit the Google Slides into the text entry as well, like a link to the Google Slides in the text entry for both of these. Okay. So really, each person's only doing 2 or 3 experiments about, right? You're not doing 10 like I did. But again, I'm a champion. So I learned a lot when I actually went through all 10, right? Anyway, gentlemen, good luck.